Hi, I'm Max Landeus, and in this video I will show how to use BetaMatch to find optimized matching networks that matches the same antenna to three different impedances. The impedances will be 50 ohm, 20 minus J20 ohm and 300 plus J300 ohm. For this demonstration we will use a single band Bluetooth antenna, and the touchstone data for this antenna comes with BetaMatch, and it can be loaded via the help menu, load demo data, and we select BT tuned high and click OK. Furthermore, we will leave the electrical delay at 0 picoseconds, and we will use the default components which are 0402 Murata components. Notice that this is based on real component data with losses and everything included. We also need to set the frequency band to the 2.5 GHz band. We go to markers menu and we select Bluetooth, and now the band is set. We can see that this antenna is tuned high. We can read the data here. Let me rearrange the table. So now we can see on the accepted power that we only have 35% accepted power at 2.4 GHz. We are now ready to start our first optimization with the default source impedance of 50 ohm. I start optimization for 4 components. Now, there, it's done. It turned out to be 3 components only needed. As you can see, the accepted power at 2.4 GHz has now improved from 35 to 73%. We save this design into memory 1 for future reference. We are now going to change the source impedance to 15 minus J20 ohm. I do it from the source editor. I open it, I enter the new values. First I enter the real part, which is 15, and then the complex part, which is plus 20, because I'm actually entering the best load, our target, which is the conjugate of the actual source impedance. I tick 2 boxes here so we can see these in the Smith chart, and as you can see now the impedance has changed to 15 minus 20J ohm. We are now going to optimize for this new source impedance. Start the optimization. There, it's done, and we have a 4 component matching network, and we can see accepted power is 71% at the band edges. Also note that the S11 plot and the Smith chart always use a 50 ohm reference. So this is what your design would look like when measured in a network analyzer in a 50 ohm system. The accepted power plot, on the other hand, shows the accepted power for the actual source impedance. If we want to see what it would have been like with a 50 ohm source, we can enable that, and that would have looked like the dotted line in the accepted power plot now. Let us store this design in memory 2. Now we'll change the source impedance again, and this time we'll change it to 300 plus 300J ohm. Open the source editor. I change the values. 300, the imaginary part will be minus 300 since we're entering the target, the conjugate. There you go. As you can see, the old matching network doesn't work at all, so we'll start a new optimization. There, it's done, and we can see that we have 72 and 73% at accepted power in the band edges. We have now designed 3 different matching networks for 3 different source impedances, so let's compare them. In memory 1 we had the 50 ohm design, and we have the low impedance, the 15 minus J20 ohm design. You can see accepted power is quite similar, they are totally different in the Smith chart. Let me rearrange so we can compare them. I will turn these off, move this one, and we will just show all matching networks in one go. So we have the data with 300 ohm design, we have memory 1 with a 50 ohm design, we have memory 2 with the 15 ohm design. We can see in the table here that the accepted power is around 71 to 73% for all the designs. That concludes this little demonstration. My name is Max Landeus, and the address to the website and my email is on the screen right now. Please feel free to contact me if you have any questions or any other feedback. Thanks for your attention.